Hey everyone, welcome back. I am absolutely thrilled you're tuning into this explainer. Today, I'm putting on my MHT CET Best Teacher hat to guide you through a true masterclass on indefinite integration. Look, I get it. This topic can kind of feel like a massive hurdle, right? But don't worry, we're going to break it all down, structure it perfectly, and hand you the exact strategies those top rankers use to score high. Get ready to totally transform your understanding and seriously boost your speed.
All right, here's our roadmap for today's high-yield review. We're looking at reversing the derivative, the standard formula toolkit, mastering the three core methods, cracking special integrals, and finally, the Liate rule hack. Let's dive right in.
Okay, Section 1, Reversing the Derivative. Let's completely demystify what integration actually is. Honestly, it's not some terrifying new concept. If you already know differentiation, you literally already have the keys. We're just working backward here.
Check out this direct relationship. In differential calculus, we were finding slopes, right? Like taking a function, say x cubed, to get 3x squared. But in integral calculus, we are on a rescue mission. Given the derivative, 3x squared, we need to find its primitive function. The integral of 3x squared with respect to x is exactly x cubed. It's really just a reverse operation, a whole concept first cooked up by mathematical giants like Newton and Leibniz.
Now this right here brilliantly illustrates why you can never, ever forget your arbitrary constant. Just look at this family of curves. Y equals x squared plus 4, and y equals x squared minus 5. If you take the derivative of literally any of these, you get exactly 2x. That means the slopes of the tangents at any given x-coordinate are identical across all these curves. So when we integrate 2x to go backward, well, we don't actually know which specific curve we're landing on, do we? That plus c represents this entire family of curves. Forgetting it is a classic MHTC trap, so don't let it catch you.
Moving on to Section 2, the Standard Formula Toolkit. Because before we can tackle the heavy-duty problems, we've got to build up our mathematical arsenal. Here's a snapshot of that foundational toolkit. You honestly need to know these so well you see them in your sleep. The integral of x to the power of n, that's x to the power of n plus 1 over n plus 1, as long as n isn't negative 1. Then you've got the exponential function e to the x, which is just delightfully stubborn. It integrates right back to e to the x. And the integral of cos x is sine x. The crucial takeaway here is rapid pattern recognition. The CET is a literal race against the clock, guys. Nailing these elementary formulae instantly is going to save you precious, precious seconds for the tougher questions.
All right, Section 3, master the three methods. Because what happens when those standard formulas don't just apply directly? You've got to master these three operational strategies.
Think of these as your ultimate problem-solving weapons: substitution, by parts, and partial fraction. Whenever you're staring down a confusing integral, your brain needs to instantly cycle through this checklist. Ask yourself, can I substitute something to simplify this? Am I looking at a product of two functions that needs by parts? Or, wait, is this a rational function just screaming for partial fractions?
Let's test that analytical thinking right now. Take a look at this expression, the integral of the linear term 2x minus 3 over the quadratic 3x squared plus 4x plus 5. Which weapon are you reaching for here? Well, it's not a standard formula. A quick substitution won't magically clear that denominator, and it's definitely not a straightforward partial fraction setup.
To conquer a linear over quadratic problem like this, you need this exact algorithmic procedure. First up, you force the numerator to look like the derivative of the denominator. Basically, set the numerator equal to a constant a times the derivative of the denominator plus another constant, b. Second step, you compare the coefficients on both sides to solve for those a and b constants. And third, you split that monster into two much friendlier integrals. The first one is going to solve perfectly by substitution, and the second one, well, that leads us right into our next vital technique.
That second part almost always leaves you with an integral of the type 1 over a quadratic. And here's exactly how the top rankers memorize the procedure to solve it flawlessly every single time. Step 1, isolate your x squared by factoring out that coefficient a. Step 2, complete the square by adding and subtracting the square of half the coefficient of x. Step 3, express that denominator as the sum or difference of two perfect squares. And finally, just apply one of your special integral formulas. If you follow these steps mechanically, honestly, you will never get lost, no matter how nasty the numbers look.
Which brings us to Section 4, Cracking Special Integrals. This phase of your exam prep is purely about pulling formulas from memory instantly. Rapid, confident recall is the name of the game. Let's look at these absolute must-memorize rules. Notice the patterns here. For instance, the integral of 1 over the square root of a squared minus x squared, that neatly yields the inverse sine of x over a. But what if it's 1 over x squared plus a squared? That gives you 1 over a times the inverse tangent of x over a. Your whole goal as a CET aspirant is to look at the denominator, instantly recognize if it's a sum of squares or a difference of squares, check if there's a root or no root, and immediately map it to the right formula. Bam! Next question.
Okay, Section 5, the LIATE rule hack. For our final major section, we are tackling a real heavy-hitter topic where students traditionally lose massive amounts of time: integration by parts. When you're integrating the product of two functions, you use integration by parts. But how do you know which function to choose as your first function, your u? You use the golden mnemonic, LIATE. That's logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. You read it left to right. Whichever function type pops up first in that word, boom, that is your u. The other one becomes v. This little trick ensures your integral actually gets simpler as you work, instead of turning into a total nightmare.
Let's do a really quick review of the standard formula. The integral of u times v is u times the integral of v minus the integral of the derivative of u times the integral of v. I know, it's a total mouthful, but with practice, it becomes pure muscle memory. Now, as your designated best teacher here, I've got to drop a major warning. Always double-check your negative signs. When you're dealing with nested integrals and derivatives, especially with sine and cosine, dropping a single negative sign will cost you those precious marks.
Now, I promised you guys a masterclass, so I'm giving you an advanced hack straight from the textbook's Something Interesting sections. When you're doing by parts and your u function is a polynomial, think x squared or x cubed, you can use this rapid shortcut. It's basically a generalized pattern. You write u times the first integral of y, then minus the first derivative of u times the second integral of v, then plus the second derivative of u times the third integral of v, and you just keep alternating those signs until the derivative of the polynomial hits 0. This shortcut is an absolute game changer. It'll smash through tricky CET questions in seconds, totally bypassing those tedious nested brackets.
So, we've covered the roadmap. You've got the fundamental toolkit, the operational methods, and the advanced hacks to slice right through indefinite integration. But I want to leave you with this one provocative thought. Speed is absolutely useless without precision. You can do all the heavy lifting. You can apply that LIATE rule flawlessly. And you can still lose it all if you forget that arbitrary constant. So, will you be the student who remembers the plus C on exam day? Keep practicing, trust the structure, and you are absolutely going to ace the MHT CET. Keep learning, and I'll catch you in our next explainer.